Many thanks for your hand clapping. So, my name is Misha Filonenko, Michael Filonenko on English style. And I work in Tarantul Solutions team. We adapt Tarantul database for customer cases. And today I will speak about domain-specific language compilation with DynASM toolset. And let me start from a small description about Tarantul and what are reasons to make my own language, because I already have Lua, and Lua is really good choice, as said Roberta. But I find case to make small domain-specific language. Tarantul is high-performance database, and Tarantul includes two storage engines, in-memory engine, and disk storage engine when RAM amount is not enough for your cases. And when I used Tarantul API to storing data, to indexing data, and to iteration over constructed indexes. And Tarantul database is high performance, and I want to store data as fast as I can, but it's already done by Tarantul core team. I can't do it faster than it is already done now. And also, I can't make indexing faster because it's already built-in feature in database. And if I have idea to make indexing faster, I have to dive into Tarantul internals and write patch. And you know, it's sometimes not so easy. But the last one point, when I want to query data from Tarantul, and data query, sorry my pronunciation, a little bit Belarusian style. First of all, I think on Belarusian language, after I translate in my mind to Russian, and only after that I translate to English. And sometimes I just stop because my brain is overloaded. It's a joke. My Russian is my native language too. Visit Belarus. Small advertisement. The data query. Usually in all databases includes two parts: iteration over index and additional filtration process. It can be, I will show you. So, and iteration over index is also built-in functionality in Tarantul database. But I want to do data query as fast as I can. And the only one point which I can to do faster is filtration process. So I want to show you a small example to understand what I mean. For example, we have a table. It's a Lua style API. We have a table with people and with 3 columns or fields. And we have index on each field or column. And we have 2 people. And we want to get people with age between 30 and 40 and do additional filtration to get only musician. So this is built-in functionality, a little bit lower. And this part I want to do really fast. Textual representation. So I want to show how to make filtration really fast. I want to show how many ways we can to use to build query to Tarantul. Tarantul API includes two level of API, C level and Lua level. And when I want to write query using Tarantul C API, I get the following pros and cons. And when I use C language, the filtration functions will be really fast because of compilation by compilers, and compilers was was made by many people man hours. And I will show benchmarks at the end. But when you want to change, for example, one criteria from musician to driver or any other, or add there, I want to add there some other criteria because, for example, I want to query only Belarusian musician. It will be fiddly on C language because I have to recompile whole source and restart my application, and there are cons. If I use Tarantul Lua API, it will be easier. You know, Lua, it's easy. Roberto said, it's easy. I use Lua, it's easy. I can say the same. But it will be slower. It will be slower despite Lua JIT. It will be slower because of dynamic types and auto-managed memory. I want to find solution to provide query builder with pros from Lua and pros from C. And why I can go from dynamic types to static types? Because usually database tables, database scheme already contains information about types. And why I can go out from automatic memory, from automatic memory manager? Because usually query is not big program. Query is just a question from user to database, and I can use hard-coded memory management. So this solution is to make small domain-specific language, not general case language, just domain-specific language, which includes just-in-time compilation, static types, and hard-coded memory management. And just-in-time compilation give me easy query construction, because you just can rewrite your query and I just compile it in time. You have no restarting. I have no restarting script. The solution is domain-specific language, and my roadmap is to build it, and I will build it by the 3 steps. First of all, I made parser of user input. The second step is to make abstract syntax tree from parsed user input, and the last one, just compile abstract syntax tree to machine code instruction. And I will use DynASM. At this step, I will show it will be so easy. So easy. Too emotional. Too emotional. Probably you don't believe me. I use S expressions for my syntax. S expression quite easy to. It's not so easy and readable for user, but it easy for me to do parser. And and I use it because of simplifying my process. Later we can speak about that. We can convert, we can translate any syntax we want to S expressions. So S expressions contains two basic types, items and lists. And lists can contain items and other lists. For example, there are items, number, string, and just symbol. The next example, there are lists. 4 lists with some items, do nothing, arithmetic, and something like predicate. I will show what I mean. My parsing includes just iteration over string with capturing items and lists. If we use more science terms, it's tokenization process, and the next step, I convert the to Lua captured items and strings. I will convert to Lua tables. I validate syntax also at this step, and it is really easy to save meta information about query source string with using Lua meta tables. Meta information to meta tables. It's logical. For example, S expression with symbol equal hello symbol and aloha symbol will be translated to simple Lua table. The second step in my roadmap is generating abstract syntax tree. Abstract syntax tree is intermediate data structure between parsed user input and compiler. Yes, it's in my roadmap. In, for example, C-lang, it will be a little bit complex with bytecode instructions. So abstract syntax tree based on rules, the following rules. The node of tree is operation, and no children are arguments for operation. For example, simple abstract syntax tree with operation hello and with 2 arguments, dear friend. And how to convert parsed S expression to ST, abstract syntax tree? Quite easy, because I use first list element is operation and other elements are arguments. The example, list with sign plus number 1 and number 2 is converted to appropriate abstract syntax tree. And I use stake-based abstract syntax tree compiler. Why? Because it is the easiest way to do things, to do domain-specific language. I will show. Because how compiler works. Compiler traverses the tree and evaluates it by the following rules. Argument nodes are pushed onto stack as they appear in the tree, and operation nodes pop operands, produce the result, and push it back. Small animation about it. Previous example with small arithmetic abstract syntax tree. First of all, we push. First of all, we push 1 argument, first argument, the second one push second argument, and the last one we make addition operation, pop all arguments, and push result back to stack. How to make compiler? And there is DynASM toolset. DynASM toolset is written by Mike Paul to make their Lua implementation, LuaJIT. He used it to write his Lua implementation. DynASM toolset was used to just-in-time compiler in first version of LuaJIT, and in the second version, toolset is used to make implementation. DynASM toolset includes 3 parts: core compiles and links code, binding to core from Lua, and translator of mixed code. Mixed code, I mean Lua mixed with assembly, and translator, preprocess mixed file with mixed code, and translate it to call to binding, which go to core. For example, it's not a compiler code, it's just a skeleton, just no operation. To make generator of your code, you just write I just write function with mixed assembly, and this assembly goes into destination when I call nope function. Pre-processing and loading mixed code is done by DynASM Lua, by the translator, which I showed on previous slides. And compiling code contains three steps: allocating compiler context, calling of generators in order you want, and linking the result to buffer. And to run generated code, I have to use FFI, and I just cast buffer to callable Lua object and call it usual way from Lua. And as I showed, that when we call generated code, nothing will be done, because nope, it means no operation, and red means return control flow back after callable. So yes, nope, return back and exit from the script. The full mixed code, the full mixed file, a little bit larger, because I have to set up architecture, I have to set up additional intermediate buffers to cache inline instructions, and additional variable to save labels, which we can't use. I think I will ask about labels when questions time. Full compiler file is easy too. Nothing new here. And when we want to compile abstract syntax tree, I want to show how it is simple. Entry point to compiler just checks if current node is atom or list, and if it is atom, compiler generate instruction to push atom to stack, and if it is list with addition operation, compiler compile first two children, first two operands, and call generator of addition operation. After my compiler or my simple compiler of query language is done, I wrote benchmarks, and the benchmarks you can see on the slide. C program is the fastest because you know optimization is really so many optimizations are in modern C compilers, and it's not so easy to make compiler better now. But it is better than Lua-G because of static typization, because in my language there are no additional memory allocations during iteration, because I pre-allocate all memory before iteration, because I do it because all memory that I need is in my query. In my language, no memory manipulation functions. And in conclusions, I want to say that it is easy to make compiler and in Lua, because Lua is dynamic and you can play with generated code really fast, pass additional context, use meta tables and other things to make some optimizations. And compiler will be just in time compiled itself, and your compiler will be fast too. For example, remember how long boost is compiled? Who compiles boost with some with some syntax error? I feel your боль. Боль. Many thanks for your attention. Many thanks for you.
Come visit Belarus.
Yeah, come visit Belarus, definitely. You can download sources from my GitHub page, and there is references to material about DynASM and about assembly. Thanks.
All right. So, guys, any questions?
Is it worthwhile to use assembly for data for manipulating the data in the database? Couldn't you use something higher levels that would gain you portability? As you said, the modern compilers are pretty sophisticated and they output highly optimized assembly anyway. So,
if I understand right, one of the reasons to make my own language is to easy query modification, and when I use static compilers, not just-in-time compilers, I have this feature, but it is critical because users just want to change query on the fly.
No. I meant why is your DSL, your meta DSL, as it were, why does it get translated to assembly rather than something higher level that would be portable between architectures?
What, for example, C?
Yeah. Like
But you have to compile C.
Well.
Yes, because when I deploy such system, I have to take C-length with me, and it's infrastructure questions.
Yeah,
It's,
the point is that you
it
don't.
is-
You only know. Sorry, you only know the query at runtime. It is possible to compile C at runtime if it do it fast, but it has its cost, obviously. And this solution a bit really simple, so to say.
Yes, and
It's also really small.
my second goal that you feel feelings of compiler constructors. I want that you make your compilers, not use only my. And it's yes, Lua better in many choices, but when you make your own compiler, you will take intuition about how your high-level code translated into the level code. And also, if you go to x96 references, you will meet microcode, you will meet pipelining, speculative, you know.
Try this at
Compilers
home.
are interesting.
Try this at home. Try this
Try?
at home.
Try this at home. Okay.
Yeah.
Okay.
So this is something you can bring home.
Try
Yeah.
this at
Ta. More questions, please.
Thank you. It was very interesting. But you have switched very fast from adding 2 and 3, adding 2 numbers, to DSL for queries. Could you tell more about the queries itself, and how does your AST looks like for queries, I mean?
Yeah, is there an equivalent
Let me repeat the
AST
question
for
in
the
Russian.
query you shown us in the beginning? Age above 30.
May I repeat the question in Russian?
Yes, I understand. I understand the question. My query builder is more complex that I showed because I implemented simple Lisp and implemented full Turing language.
Turing complete.
Complete.
Is that the link?
Yes, and
Yes.
you will find the full query in my
Okay,
in my repo.
I will check.
So have you seen Lisp?
Yes.
Who's have seen Lisp? Okay, not everybody.
Not too bad.
Everyone else look at Lisp. It will do you good. So he's done Lisp, Lisp
Custom.
1, I think.
Yes, Lisp 1 and really custom without dynamic, without.
Simple less.
And this simplest.
Okay.
Whew.
Hello, thank you for the talk, and just would like to clarify which operations does your compiler actually support apart from basic arithmetics? I mean, addition, subtraction, multiplication. What else do you have? Was it difficult to implement it? How much difficult was it implemented in direct assembly?
I implemented arithmetic and
And a black screen.
okay. I implemented arithmetic, bit operations, calling to external functions, and lexical binding operation, and set operator for lexical binded variables.
How difficult was it? It was.
Yes, okay. And
How many hours?
operator if and operator and special form do with subform break and continue. So and the difficult is operator if conditional operator, because model of execution of if operator have to think about arguments, not like about function call arguments, but about arguments which will be evaluated independent depends on condition.
Okay.
Yes.
And how much time in total did you spend? How many hours on this implementation? Roughly.
How many hours? I think
Weeks, years.
40.
40 hours.
40
so
hours.
A week.
But 40 hours. But previously I translated Common Lisp, the language book, from Guy Steele, and translation of book few power of my
So you
knowledge.
You the Lisp.
Yes.
Okay.
Thank you.
Thank you too.
Look at Lisp, guys.
Common Lisp.
Come on, Lisp.
Common. This is Lisp too.
Okay, more
Those are
questions,
Russians.
please.
Thank you.
Who was the first? He was the first. You will be the next.
You use this dynamic ASM in Tarantul?
Not yet.
Not yet?
When?
Not yet
When?
in production. When? So now the question is to lobby it through Konstantin Osipov. I said it on the camera.
Okay. Okay, good.
I will try.
Use for the DSL or select? Right?
I have to discuss about it with many people because now it's just in my head. It probably not so comfortable to other people, and also there is SQL language, you know, and if I switch to SQL just-in-time compilation, probably it will be more practical for society.
I've got a thought. You implemented Lisp 1, basically, simpler, Lisp 1, and Lua is Lisp 1, so maybe change syntax to Lua.
Yeah, yeah, yeah. I think about, but when I try to change syntax, I have to make automatic type resolving.
But why?
For faster.
And in S expressions, do you have the explicit syntax?
In expressions, I use only one type, int 40.
Okay, but you can, I think you can have Lua with only one type.
Something
language
like
with Lua
sub-Lua.
syntax?
Something syntax from
Yes,
Lua
yes.
and a subset of Lua.
Yeah, because
Syntax.
S expressions are really nice, but
Yeah,
nowadays,
I
sadly,
love.
hardcore.
But after after limit, after intuition limit of amount of code, as expressions become unreadable.
Yeah. Who tried to code in S expressions? Or Lisp? Obviously, Roberto tried to code. Did you code in Lisp ever? Yes. So Roberto can raise the hand too. And, who stopped coding in Lisp because he hates it? Okay. I love Lisp, but I don't code it in it still. Okay. Another question, please.
Меня зовут Василий. Спасибо за презентацию. Можно на русском скажу, чтобы никого не мучить?
I will translate.
У меня такой вопрос. Мне интересно, я видел книжку, называется Build Your on Lisp, если не ошибаюсь.
There's a book, Build Your Own Lisp.
Да, и там было вот очень все похоже. As expression, Polish notation.
It was really similar as expressions, Polish notation,
Опирались
sorry.
ли вы на эту книжку, может быть, или какую-то имплементацию тут брали? Там есть библиотека MPC, если не ошибаюсь. Опирались ли вы, может быть, на нее?
Did you use this book or libraries from there in implementing that?
No, no. But there was no innovation. It is как это, general common solution to make compilers.
The Lisp is so simple. Why would at this level? Why would you need a library? Okay, thank you. More questions? So, no one? Well, thank you very much. Let me shake your hands.
Thank you.